First question is, which are the important formulas used to measure thermal time constant tau and response of temperature measuring instrument? Second question, solve one problem for thermal time constant.
Let us understand the concept of thermal time constant tau and response of temperature measuring instrument. Now the temperature measuring instrument we will use here thermocouple. So here is the diagram where this junction is having diameter d. So this junction is of spherical shape and there is the gas is passing over this junction of the thermocouple and this gas is having temperature Tf and the convective heat transfer coefficient is known as H. Now the initial temperature of this junction at time t is equal to 0 is T0 and after time t the temperature of this junction will become T and here is the surrounding fluid, that is the gas temperature is Tf. Now when we take the difference in between this T0 and Tf, it will known as theta 0 and this temperature difference T and Tf is known as theta. Now this is the application for the lumped parameter analysis. So for this the lumped parameter analysis we have seen in the previous video, that is when this internal temperature gradient is negligible, then that is the case of lumped parameter analysis. So in this case also internal temperature gradient should be negligible. Now we will move for the response of the temperature measuring instrument. So here in this case we will use here the thermocouple. So how we can measure the response of thermocouple? So response of thermocouple, that is equal to time required for thermocouple to attain the source temperature. Now here this is the junction and we have to measure this small t, that is the time t required to attain the source temperature, that is required to attain the temperature of the surrounding fluid or surrounding gas. Now when this response of this thermocouple is rapid, so there is the value. So when this internal temperature gradient is negligible, then for unsteady state we will use the formula theta by theta O is equal to e raised to minus HAT by rho CPV. So this is the formula that we use. So response is rapid when this value HAT by rho CPV is larger. So we have to always keep this value larger. So for that we can say that this H, that is the heat transfer coefficient, should be maximum and here is the volume that should be minimum. So we can say that this diameter or the wire should be minimum. Now what is the value of tau? That is the thermal time constant. So thermal time constant, that is nothing but rho CPV by HA. So we can rewrite this as theta by theta O is equal to e raised to minus HAT by rho CPV. So instead of this HA by rho CPV, we will replace this with 1 by tau. So here e raised to minus t by tau. So for the questions for the thermal time constant or for the thermocouple, we will use this formula theta by theta O is equal to e raised to minus t by tau, where tau is the thermal time constant.
We will read the given question. A thermocouple junction of spherical form is to be used to measure the temperature of gas stream. Take convective heat transfer coefficient H is equal to 400 watt per meter square Kelvin. Thermal conductivity 20 watt per meter Kelvin. Specific heat 400 joule per kilogram Kelvin and density 8500 kilogram per meter cube. Calculate the following. First, junction diameter needed for the thermocouple to have thermal time constant of 1 second. Second, time required for the thermocouple junction to reach 198 degrees Celsius if The junction is initially at 25 degrees Celsius and is placed in a gas stream which is at 200 degrees Celsius.
Now we will move to the first question. We have to determine diameter for the thermocouple junction. Now if we observe the diagram, here is the junction and this junction we will consider as a sphere. So remember, for this thermocouple junction we have to apply all the formulas for the sphere. Now we have to find out diameter d. So here is the diameter d that we have to find out. That means we have to find out the diameter for the sphere. The thermal time constant is also mentioned, that is value of tau is equal to 1. Now we know that what is the formula? 1 upon tau is equal to HA by rho Cp V. So 1 upon tau is equal to 1, which is equal to H. So convective heat transfer coefficient 400, area of sphere 4 pi r square, rho that is density 8500, specific heat 400, volume 4 by 3 pi r cube. Now we will simplify this. This 4 pi r square and 4 pi cube is getting cancelled. So here only r remains. That is, this r square and r square is getting cancelled. So here r by 3 is there. So when we solve this, then we will get that is 400 and in the denominator 1133333 into r. So r is equal to 3.5 into 10 raised to minus 4 meter. But here we have to find out the diameter. So here is the radius of the sphere, that is radius of the junction. So if we multiply with 2, then 7.05 into 10 raised to minus 4 meter. Now if we observe, we will convert this into millimeter, that is 0.7 into 10 raised to minus 3 meter, and which is equal to 0.7 millimeter. So this is the answer of first question. Now we will move to the second question. So here initially at time t is equal to 0, temperature of the junction T0 is 25 degrees Celsius and this gas temperature is 200 degrees Celsius. So for some time, that is time t, heat transfer is taking place and temperature of this junction will reach to 198 degrees Celsius, and we have to find out what is that time period t. Now we have to first find out what is the Biot number to write the formula. Now if we observe this junction, we have to consider as a sphere. So what is the characteristic length of a sphere? So characteristic length L is equal to V by A. So volume 4 by 3 pi r cube divided by surface area 4 pi r square. So which is equal to r by 3. So Biot number Bi is equal to HL by K. So convective heat transfer coefficient H is 400, characteristic length r by 3. So radius r that we have calculated 0.35 into 10 raised to minus 3 divided by 3 into K, conductivity K 20. So 2.3 into 10 raised to minus 3. So this value is less than 0.1. So internal temperature gradient is neglected. That means this is the application for the lumped parameter analysis. So we will use the formula, that is theta by theta O is equal to e raised to minus t by tau. Now why? This tau is thermal time constant and the value is mentioned in the question. So we will directly use this formula. So theta is 198 minus 200 and theta O, that is 25 minus 200, which is equal to e raised to minus t, and tau is 1. Now we will solve this. Minus 2 by minus 175, which is equal to e raised to minus t. Now if we observe the calculator, then here we will take the inverse of e on both the sides. So inverse of e, that is ln. So we will take ln in the bracket. This minus minus is getting cancelled. So ln in the bracket 2 divided by 175 bracket complete. So its answer is minus 4.47. And here e inverse and e is also getting cancelled, and we will write here as a minus t. So t is equal to 4.47 seconds.